In the last module, we saw a few examples of results of calculus that seem geometrically obvious, but in fact lurking underneath is a subtlety. One might think that such subtleties might arise only when complicated concepts such as continuity or derivatives are involved. But actually, even in simple logical puzzles, sometimes human beings are not so good at identifying the key. Here is a famous psychological puzzle called the Wason selection task. Before I explain the task, let me first say that please don't feel bad if you are not able to solve this puzzle, and don't feel too good if you are able to also. This is a puzzle that has been found to be unsolvable by most people who are attending colleges. So let me describe the puzzle for you. You see on the table in front of you 4 cards. Each card has 2 faces. One face has a number, the other face has a color. So you see these 4 cards displayed in front of you on a table. Obviously you cannot see both faces. The face that is towards the table is not visible to you. So here we see the cards with faces 3, 8, red, and what I think is the color brown. Behind these cards, of course, the first 2 cards, there will be some colors. Behind the third and fourth card, there will be some numbers. Suppose you want to test the following statement. Behind a card whose face has an even number, the face has color red. That is, whenever you see one face that has an even number, then the opposite side must be red in color. Suppose you are asked to test this proposition for the 4 cards that you see here. Obviously, one easy way to check that is to flip over every single card. But you don't need to flip over every single card. What are the cards that you actually need to flip to check this proposition? I will pause for a while, think for a few minutes, and try to figure this out. Okay, hopefully you have thought about this. Now, let's see the answer to this question. I'm going to solve this question in excruciating detail, step by step. Let's look at the card that says 3, that has one face 3. Is there any need to flip over this card to see whether the opposite side is red in color? No. So this card, no flip required. Why is that? Because if you look at the statement, behind a card whose face has an even number, the face has color red. That means the assertion, the proposition is purely about those cards which have one face even number. The card that has face 3 is not an even number. 3 is not an even number. Therefore, it doesn't matter what color is opposite this face. It's completely irrelevant to the truth of the given proposition. Okay. Second, card that has face 8. Obviously, you need to flip this. Obviously, you need to flip this because you have to check that the opposite side is in fact red. So, card that has one face 8, flip. Now, third one. Here is where some people make a mistake. Some people say you need to flip the card that has the face red. But you actually no need to do that. Why? Because there are only 2 possibilities for the opposite face, either an odd number or an even number. If it's an odd number, then regardless of whether this is red or brown or black or cyan, it really doesn't matter. Because the proposition that we have does not assert anything about cards that have one face an odd number. So, card that has one face red, no flip. It is completely irrelevant whether the opposite face is even number or not. That's not what the proposition is saying. It is not saying that if one face is red, the other face should be even. So it's completely irrelevant. What about the fourth one? Fourth one, card that has one face brown, a flip is required. Why is a flip required? Because if the opposite side is odd, then it's not a problem. But the opposite face, if it's actually an even number, then this particular last card is going to be violating the proposition that behind a card whose face has an even number, the face has color red, this would be violated. Okay, so I have now explained the solution in excruciating detail. This puzzle is fairly straightforward once you write it down in this way. But most people, when confronted with a puzzle, do not take out a paper and a pencil and start writing down in such great detail. Consequently, it turns out that even this simple puzzle, a vast majority of college-going students do not get it right. They believe that you have to flip the red card or not flip the brown card, so on. Various errors are possible. What is funny is that this entire setup can be rephrased in terms of a social situation involving a bar and checking ID cards to ensure that the patrons of the bar are all over the legal age limit for drinking. I urge you to look through the Wikipedia article on Wason selection task to know more about this. So, what is the moral of this puzzle? The moral of this puzzle, quoting the famous Professor Scott Aronson, is humans are designed to spear small animals, not to do abstract logical mathematics. So, we are in our evolutionary history, survival was the main goal. Even today, it is not entirely clear how extreme abstract thinking is of benefit to survival. There are various possible theories given by various people how abstraction is very useful, but nevertheless, it is not clear that survival and logical thinking are really mutually beneficial. So, in the rest of this course, we will be very careful when we write down proofs and be very detailed. The reason being that is, even if you cannot solve such simple puzzles without being detailed and rigorous, how are you going to be able to do calculus where there are a lot more subtleties? So see you in the next module where we will see yet another puzzle.